we're going to sneak up on a certain fact. I want to show that pi is less than 22/7. These are awfully close. Pi is about 3.1416 and 22/7 is about 3.1429, right? These are awfully close. And we'll do it with an ansatz. I'm just going to make something up and it'll turn out, in retrospect, to be exactly what we need. So the trick's going to be to do the integral from 0 to 1 of x to the 4th times 1 minus x to the 4th all over 1 plus x squared dx. How do I integrate that? Before we actually do the calculation, let's notice something about the integrand. The denominator here is positive, and the numerator, well, as long as x isn't 0 or 1, the numerator is positive as well. It's continuous, and I'm integrating a continuous function that's mostly positive except at the endpoints. Well, that means that this integral ends up being positive as well. We'll need that fact later, the fact that the integral is positive. But let's work now on the integrand. I'm going to focus first on the numerator. 1 minus x to the 4th, if I just multiply this out, I get x to the 4th minus 4x cubed plus 6x squared minus 4x plus 1. And now if I multiply this by x to the 4th, right, that just adds 4 to each of these exponents. This will be x to the 8th minus 4x to the 7th plus 6x to the 6th minus 4x to the 5th plus x to the 4th. Let's get ready to do some long division. So I'm just going to copy this down. So what did I get as the numerator? What was x to the 4th times 1 minus x to the 4th? Expanded out was x to the 8th minus 4x to the 7th plus 6x to the 6th minus 4x to the 5th plus x to the 4th. And I want to take that numerator and I want to divide it by 1 plus x squared. So I'm just going to do long division. I'm dividing this by, I'll write it as x squared plus 1. Okay, so that's the calculation I want to do. I want to do this long division problem. Well, I got to put something up here that I multiply by x squared plus 1 to kill x to the 8th. And for that, I could use x to the 6th, because x to the 6th times x squared is x to the 8th, and x to the 6th times 1 is just plus x to the 6th. And I'm going to subtract that, and what do I get? Well, the x to the 8th terms cancel, and I've got a minus 4x to the 7th. 6x to the 6th minus x to the 6th is 5x to the 6th. Minus 4x to the 5th and plus x to the 4th, those survive. I'm not subtracting anything. I'm just going to copy them down. Minus 4x to the 5th plus x to the 4th. All right, now I got to put something up here that I can multiply by x squared plus 1 to kill minus 4x to the 7th, but minus 4x to the 5th, because that times x squared gives me minus 4x to the 7th, and that times 1 gives me, minus 4x to the 5th. That's great. So this term dies and this term dies, and I'll just copy down the terms that survive, which is 5x to the 6th plus x to the 4th. Now what do I put up here to multiply by this to kill this? Plus 5x to the 4th will do it, because that times x squared gives me 5x to the 6th, and 5x to the 4th times 1 gives me plus 5x to the 4th. Now remember, I'm subtracting this, so that kills this first term, but here I've got, what, minus 4x to the 4th. I'm going to write that over here. So minus 4x to the 4th is all that's left. I got to put something up here to multiply by this to kill this. How about minus 4x squared, because that times this gives me minus 4x to the 4th, and then minus 4x squared. I'm subtracting this, so this becomes just 4x squared. Now I got to put something here to multiply by this to kill this. Well, plus 4 will do it. Plus 4 times that gives me 4x squared plus 4. And when I subtract this, I get minus 4 left over, and that's my remainder. Now we can rewrite the integral. So in light of the expansion of the numerator and the long division after I divided by 1 plus x squared, this is the integral from 0 to 1 of, well, what did I get when I divided? Was x to the 6th minus 4x to the 5th plus 5x to the 4th minus 4x squared plus 4. And then I had a remainder, so minus 4 over 1 plus x squared. This is an integral I can do. Okay, this is x to the 7th over 7. That's the antiderivative of x to the 6th. An antiderivative here is minus 4x to the 6th over 6, plus an antiderivative here is just x to the 5th. Antiderivative here is minus 4x to the 3rd over 3. Antiderivative of 4 is just plus 4x. And an antiderivative of 4 over 1 plus x squared, well, the antiderivative of 1 over 1 plus x squared is arctan. So this is minus 4 arctan x. And I'm integrating from 0 to 1, so I'm just going to evaluate this from 0 to 1. Now, what do I get when I evaluate this? Well, when I plug in 0, I get 0, 0, 0, 0, 0, and arctan of 0 is 0. So I end up just subtracting 0. So I only have to just evaluate this at 1 to figure out what this integral is equal to. So when I plug in 1, I get 1/7 minus 4/6 plus 1 minus 4/3 plus 4 minus 4 times, and what's arctan of 1? Well, arctan of 1 is pi over 4. Let's simplify a bit. So I've got 1/7, and I'll put all these with a common denominator of 3, so minus 2/3 plus 3/3 minus 4/3 plus 12/3. And then minus 4 times pi over 4 is just minus pi. Well, now what do I have? Let's see here. So I've got minus 2 minus 4, that's minus 6/3. 3 plus 12, that's 15/3 minus 6/3. That gives me 9/3 left over, and then also minus pi. So I've got a 1/7 plus, well, 9/3 is just 3. Minus pi. Well, 1/7 plus 3, that's 22/7 minus pi. Here's the significance of this. Remember back to the beginning. Well, way back at the beginning, I pointed out that this integral is positive. So what have we shown? So we've shown that this, the value of the integral, is positive. In other words, that 22/7 is bigger than pi. So this is really a fun example. We've got all these pieces coming together. We've got the derivative of arctan, long division of polynomials, the fundamental theorem of calculus, all these forces combining to convince us that 22/7 is bigger than pi. So if you want an entertaining challenge, here's an even more complicated integral to evaluate. The integral x goes from 0 to 1 of x to the 8th, 1 minus x to the 8th, times 25 plus 816 times x squared, and all of that over 3164 times 1 plus x squared. I think the answer that you get here is pretty entertaining.